So let's start. So I think we have done a few problems in the last class. So let's do problem number 5. Okay. Till 4 we did, I think. Okay. So let's do 4. Ma. Yeah. So P is a normal silo P subgroup.
দাদা স্ক্রিন শেয়ার করতে
Oh, sorry. So P is a normal silo P subgroup of a finite group G. Okay. And if G to G is an endomorphism. Okay. So endomorphism means it's a it's a surjective map, na? So P is a normal silo P subgroup. Okay. Then they are saying if P is a subgroup of the P. Okay. So how do we do it? So G to G an endomorphism. P is a normal subgroup. So what about FP? What is it? First, understand that since, do you remember this? P is a silo P subgroup, then P is normal if and only if P is unique. Okay. Okay. Now tell me, what is F? So mod P, P has order. Okay. This, but what about FP? What should be the order of FP? What do you think? So suppose G belongs to FP, right? So there exists X belongs to P such that Fx is G, right? So X, order of X is P to the power something, let I. So f of x to the power I, which is f of x whole to the power I, is g to the power I, right? Thus order of G also p to the power some j where j less than I, right? So if p is also a, so I mean, so if p is also a p group, right?
সাবগ্রুপ হবে। হুম।
If p is a p group, subgroup of subgroup is a p group, sorry, right? So if p is contained in some silo p subgroup, right? But p is unique silo p group of G. Okay, okay, understood. But I am not really sure where did we use the fact that F is an endomorphism. That is, I mean, that is one thing which is stuck in my mind. I mean, where did we use the fact that F is an endomorphism? What about 6? Okay, so what about 6? মা, দরজাটা দিতে বলে দাও না কেন তুমি? দরজাটা দিতে বলে দাও না কেন? দরজাটা দিতে 3 বার বললাম, দিলে না কেন? Okay, so the thing is, how about this? If H is a normal subgroup of order p to the power k of a finite group G, then H is contained in every silo p subgroup of G. Okay. So H is a normal subgroup of order p to the power k of a finite group G. So H is H is a normal subgroup of, then H is contained in every silo P subgroup of G. Okay. So suppose P is a silo P subgroup of G. Okay. Okay. There, I think there was something. I mean, I think there was a result somewhere here.
মানে সিলো ফার্স্ট থিওরেম থেকে তো
Hmm.
উম, যে একটা অন্তত সিলো সাব গ্রুপেতে কন্টেইন করে করবে এইচ,
Uh,
তারপর যদি সিলো সেকেন্ড থিওরেমটা অ্যাপ্লাই করা যায় যেটা
yeah, I'm probably looking to use that. Yes, there it is. Okay. P is any silo P subgroup. Then there exists X belongs to G such that H is subgroup of this. Okay. For any P subgroup, this happens, right? True, na? So there exists XP such that H is subset of XP, P XP inverse, right? It means XP inverse H, XP subset of P. But H is normal, so this is H, na? Okay. Okay. This is by Sylow's second theorem. Find two silo subgroups and silo 3 subgroups of Iki. Iki. Two silos and silo 3 subgroups of this. Okay. So what is the cardinality of S3? 6. Cardinality of S4? 24. Right? So these are groups of order 2, no? Here is groups of order 8, and there it is also 2, 3, 8, 3, 8, 3. So these are generated by ij, right? ij belongs to 1 2 3, and this is generated by 1 2 3, the Silos-Tree subgroup. What about this? This generated by ijk, Silos-Tree subgroup, where ijk belongs to 1 2 3 4. What about this? What about the 8, subgroup of order 8? What is that? Okay, Silos-Tree subgroup has total 9 elements. Generated by 1 2 3. What about the Silo 2 subgroup? What about that? 8 order subgroup of S4. Okay, so I mean this is computation just. I mean these joint 2 cycles will be there, 1 2 3 4 will be there. Party node. So I hope you can complete this solution because this is just computation, okay? What about the next problem? If every silo P subgroup of a finite group G is normal for every prime P, then G is direct product of silo P subgroups. This is a very good problem. Okay, so how to show it? At least try.
মানে ইন্টারসেকশনটা শুধু আইডেন্টিটি থাকবে এটা প্রুফ করতে হবে তো, মানে সিলোপ্রি সাবগ্রুপ গুলোর।
You can show that as well. আমরা এটা কত নম্বর চ্যাপ্টার করছি?
দাদা,
বলো।
আমরা যদি একটা কমন এলিমেন্ট ধরে নিই এক্স, মানে মানে ইন্টারসেকশনে মানে নন এমটি ধরে নিলাম, মানে নন এমটি নয়, আইডেন্টিটি ছাড়াও একটা এলিমেন্ট আর কি, তাহলে মানে সেই এলিমেন্টটার অর্ডারটা তাহলে তো উম, দুটো আলাদা মানে প্রাইমকে আর কি ডিভাইড করছে, মানে পিআই এর অর্ডার আর পিজে এর অর্ডার, এরকম ভাবে কি এগোনো যাবে?
I'm thinking as well. So finite group. So what about, just a minute, where did the pen go? Just a minute. I had the pen in my hand. Okay. Yes, Subrita. So what are you saying? So every silo p subgroup of a finite group G is normal for every prime p, right? So all the silo subgroups are unique, right? Hmm? Right? For any p. So one thing we are sure, that if P is a silo P subgroup, or maybe P1 is a silo P1 subgroup, and Q1 is a silo Q1 subgroup, then P1 directs from Q1, I mean isomorphic to P1 Q1, is normal in G, right? That's true, na? This is normal, because if you take X belongs to G, then X P1 Q1 X inverse, you can write this way, right? So this is P1 and this is Q1, thus you get P1 Q1. So this is a normal subgroup of G, okay? So suppose G1 is mod G is P1 to the power, maybe write this way, just a minute. P2, okay, Pn to the power Qn, okay? So thus from this we say this P1 to Pn, which is isomorphic to normal in G, right? That's true, na? But what is this? What is the cardinality of P1 to Pn? What is that? What is cardinality of P1 P2? Tell me. What is cardinality of P1 P2? This is cardinality of P1 into cardinality of P2 into cardinality of P1 intersection P2. Now what Shubrita was saying, that if X belongs to P1 intersection P2, then order of X should divide P1 to the power Q1 and P2 to the power Q2, right? This implies order of X is 1, which implies X is E, right? So this is 1 and this is this, right? So from this we can say that cardinality of this is cardinality of P1 times cardinality of Pn, right? Which is P1 to the power Q1 up to Pn to the power Qn, which is cardinality of G. Understood? So P1 to Pn is basically G. Okay. Okay. What about, this was 8. What about 9? What about 9? Just a minute. What about 9? Yeah, Shubhrita, what you have done is correct. Okay, try this for 2 minutes, 2-3 minutes. I have to take some water, please. Excuse me. Okay. So P is greater than Q, right? They are saying Q contains a unique normal subgroup of index Q. That is the silo P subgroup of G is normal. Right? That's what we have to prove. Right? That is the silo P subgroup of G is unique. Right? So what is the number of silo P subgroups? What is that? It is NP plus 1, right? I mean NP is of the from Kp plus 1, na? NP is of the from Kp plus 1, right? Which divides Q, right? But Q is less than P. So Kp plus 1 does not divide Q if K is greater than equals to 1. So K is 0. NP is 1. We are done. Okay. Try 10. Try 10. Try it for 2 to 3 minutes. See, I don't know whether you have tried it or not. That's why I want you to try it now. Otherwise, if you are only watching the solution, it won't help you much. না 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 আমি দিয়েছি তো তোকে একটা আগে না কাল সকালে খাবে What about this? So 12, right? For 12, if you can see that, so let's see, 12, 28, 56, 200. So what is the breakup of it?
ফিফটি সিক্সে 7 হবে।
Uh-huh. Okay. So first of all, for this, okay, so what is n2? N2 is of the form 2k plus 1 and it must divide 25, right? And n5 is of the form 5k plus 1 and it must divide 2 cube. Okay, so if k is greater than equals to 1, n5 does not divide 2 cube, right? So k equals to 0, which means n5 is 1. So the silo 5 subgroup is normal. Okay. Okay. Now for this, again 2k plus 1. Let me see the easier ones. Yeah, again. So n2 is 2k plus 1 and it divides 7. N7 is 7k plus 1 and it divides 4. So N7 has to be 1, na? So again, the silo 7 subgroup is normal. But what about this? So N2 is 2k plus 1 and it divides 3. So what are the options for this? 1 or 3. And N3 is 3k plus 1 and it divides 4. So the option is 1 or 4. Okay. So if N2 is 3 and N4 is 4, what do you get? I mean, N3 is 4. So there are 3, N2 is 3, right? So there are 3 subgroups of order 4, right? Right. There are 3 subgroups of order 4, right? So the intersection can be at most 2, right? So the intersection can be at most 2. This should be the structure, because if the intersection is 1, we are coming to that case. Okay. So there are 8 elements, right? The group has order 12. Wait a minute. N3 is 4. So N3 cannot be 4, na? Clearly. So they have total 8 elements, right? So there are only 12 minus 8, 4 elements left. So N3 cannot be 4, right? So N3 is 1. Okay. And similarly, if N3 is 4, N2 will be 1. Okay. The case here is also similar. Okay. If N2 is 2k plus 1 divides 7, and n, so this is 1 or 7, and n7 is 1 or 8. Okay. So if N2 is 7, then there are, how many elements are there? See, non-identity elements in a group of order 8 are 7, right? So you get 7 into 7, since N2 is 7, that is 49. Hence the group of order 7 is unique. Okay, understood? So the group of order 7 is unique. Okay, because there is only 56 minus 49, 7 elements left. And if N7 is 8, then how many elements are left? 6 into 8, 48 elements are gone. So the group of order 8 is unique. Okay. Okay, try to do this 11. Try 11. So what is the breakup of 168? Right? Okay. So N2 is 2k plus 1 and it divides this. N3 is 3k plus 1 and it divides. N7 is 7k plus 1 and it divides. Okay. So tell me, what should be N7? If N7 divides 24, then N7 is
8.
1 or 8. But it cannot be 1, na? Because the order of silo 7 the silo 7 subgroup then becomes unique, hence normal. So there are 8 silo 7 subgroups, right? 8 silo 7 subgroups. 8 silo 7 subgroups. Each containing 6 non-identity elements, right? Each of them each of them has order 7, right? So 8 into 6, 48 is the answer. Every group of order p square is abelian. Can we read? So we know that Zg is non-trivial, right? From class equation, remember, from class equation we know that Zg is non-trivial, right? Pre-group has non-trivial center, no? This was done in probably the first or second class.
হ্যাঁ দাদা।
So mod Zg is p or p square. If mod Zg is p square, then g is equal to Zg, implies g is abelian. If mod Zg is p, then mod Zg is p which implies Z mod ZG is cyclic, right? Which again implies G is abelian. This was also done in the first exercise, right? Hence it is done. Let's discuss 12. Okay, I will expect you to try this at home, but we will discuss this to some extent. Okay. See, there is a hint given. If F is an automorphism from S4 to S4, then suppose P1 is 1, 2, 3, P2 is 2, 3, 4. P3 is 1, 3, 4, and P4 is 1, 2, 4. Okay. So one thing should be obvious to you, that if sends 3 cycles to 3 cycles, if keeps the cycle structure unchanged. Okay, check this. So what is, if f of p1 is, suppose if f of pi is pi for I running from 1, 2, 3, 4. Okay, suppose f of 1, 2, 3 is 1, 2, 3. Okay. So what is f of 1, 2? Anyone? What is f of 1, 2? It is 1, 2 or 1, 3. Do you understand why? f of 1 to 3 is 1 to 3, right? So f of 1 2, I mean, what is this? So it means f of 1 3 1 2 is f of 1 3 1 2, right? So f of 1 2 cannot have any other digit apart from 1 2 and 3. Okay. Can it be 2 3? But if f of 1 2 is 1 3, then this will problem f of p4 is not p4, implies f of 1 2 is 1 2. And similarly you will see f of 1 3 is 1 3, 2 3 is 2 3. Similarly f of ij, we will see it is ij. So f is identity. Okay, so I will leave it up to you to complete the solution, or else we will do that in the next class. We will probably start a bit of rings, UFDs in the next class. Let's see. Okay, bye. Need to teach you some, at least some ring theory. Ring theory is very vast. The problem is that